We want to determine if the given infinite series converges or diverges. So looking at our infinite series, notice how a sub n contains this fraction raised to the power of 2n, and because it's raised to the 2n power, we should recognize that the most appropriate test would be the root test. So let's review the root test before we apply it. For the root test, if we're given the sum of a sub n with the limit as n approaches infinity of the nth root of the absolute value of a sub n equals L, then the value of L can tell us whether the series converges, diverges, or if the test fails. If L, the value of the limit, is less than 1, then the sum of a sub n converges. If L is greater than 1, then the sum of a sub n diverges. And if L equals 1, the test fails, and we have to apply a different test. And again, this is normally the test to use if the series is raised to the nth power, or in this case, raised to the 2n power. And notice that since n starts at 1, a sub n is always positive, so we can drop the absolute value. So we want to find the limit as n approaches infinity of the nth root of a sub n. So we'll have the nth root of a sub n, which is 4n divided by the quantity 2n minus 1 to the 2nth power. And now I'm going to write this using a rational exponent. Remember that if we have the nth root of a sub n, then this is equal to a raised to the power of m divided by n, where the exponent is the numerator and the index is the denominator. So this is equal to the limit as n approaches infinity of 4n divided by 2n minus 1 raised to the 2n divided by n power. Well, notice how this just simplifies to 2. So now we have the limit as n approaches infinity of 4n divided by the quantity 2n minus 1 squared. Now let's go ahead and square the numerator and denominator. So we'll have the limit as n approaches infinity. Well, 4n squared would be 16n squared. And for the denominator, we'd have two factors of 2n minus 1. Let's go ahead and multiply this out. We would have 2n times 2n, that's going to be 4n squared. And then 2n times negative 1, and then negative 1 times 2n, that's minus 4n. And then negative 1 times negative 1 is plus 1. Notice in this form, the degree of the numerator and denominator are the same, which means this limit is equal to the ratio of the leading coefficients, which would be 16 divided by 4, which is equal to 4. And since 4 is greater than 1, again, by the root test, we know that the given series diverges. So let's go ahead and summarize this. By the root test, since the limit as n approaches infinity of the nth root of the absolute value of a sub n is equal to 4, which is greater than 1, the given series diverges. Okay, I hope you found this helpful.